Welcome back. In this second video, we're going to go ahead now and look at our properties of exponents. So grab a piece of paper and a pencil and get ready to take some notes. Go ahead and take a moment to write down this table for your notes today on your piece of paper. We're going to start by looking at what's called a product of powers, which really just means what happens when you're multiplying two powers together that have the same base. And that's actually a good point. So I'm going to add that to my list. There we go. With the same base, because if they don't have the same base, then there's only so much that you can actually do with them. So in our table, we have, in the first column, we're going to be looking at our expressions, our products. We're going to expand those powers, and then we're going to simplify them. So our first example that I want you to look at is 2 to the third power times 2 to the fourth power. Now, when we are using our properties of exponents, we don't actually have to know what 2 to the third power and 2 to the fourth power are, but we can use that to check our final answer. So the first thing that we're going to do is I notice that it is a product. I am multiplying two powers together, and they both have the same base. If you're not multiplying and they don't have the same base, then this will not work. So as long as you're multiplying with the same base, here we go. We're going to go ahead and expand those two powers into products. So the first one, 2 to the third power, if we remember, that just means 2 multiplied by itself 3 times. So I'm going to expand that as 2 times 2 times 2. So this is our first power in the expression, 2 to the third power. Now I'm continuing that multiplication because it is times, and then we're going to expand 2 to the fourth power. 2 times 2 times 2 times 2. So that second part here, that's the second power expanded. So what you might notice is all we did is we continued to multiply by 2s. Now where it says simplify, sometimes that means go in there and do the math. 2 times 2 is 4, times 2 is 8, times 2 is 16, and etc. Or we could just write this as a single power. So notice how all of the bases are 2. How many total times am I multiplying by 2? 1, 2, 3, 4, 5, 6, 7. So I can write this as 2 to the power of 7. And that's how you apply what's called the product of powers. So I started with a product of two powers that had the same base. I expanded it out, and then I wrote it as what's called a single power. And then from there, if you want to actually figure out what 2 to the 7th is, you could, or you could just leave it as 2 to the 7th. Let's try another example. This time let's use a variable x. What if I had x to the 5th times x squared? Okay, x to the 5th times x squared. Is it a product? Am I multiplying? Yes. Do both powers have the same base? Yes. That means we're looking at a product of powers, so we can expand and we can simplify. Let's go ahead and do that. X to the 5th expanded means x times itself 5 times. That was a lot of x's, right? So this is your first power expanded. Now we're continuing that multiplication. Times x squared means x times itself 2 times. So here's the second power expanded. Now, because it's just all of these x's are being multiplied by themselves, we just ask ourselves, how many total times are you multiplying x? 1, 2, 3, 4, 5, 6, and 7 again. Look at that. So we would write this as x to the power of 7, because x to the power of 7 really just means, hey, go and multiply x by itself 7 times. These are equivalent expressions. I'm going to give you now I'm going to give you one that you can try on your own. Let's see how well you do with this next one. What if it was y to the third times y squared? Why don't you go ahead and try that one on your own, and we'll see how you do. You can pause the video now, and let's go over it. Just because there are 3 powers here, it's still a product. I'm still multiplying, and they all have the same base of y. We'll look at an example next that doesn't have the same base. So that just means I can expand and simplify. So let's start with y to the third power. Y to the third power is y times y times y. That's what y to the third power means. Now, what about that second y? Should we include that? Of course we should include that, right? That's just a single y. In fact, y by itself could also be written as y to the first power. Sometimes you'll see that in math. So there's our second power. And then our third power times y squared means y times y. So there's our third power. Y squared is y times y. All right, how many total times are we multiplying y? Let's add them up. 1, 2, 3, another 1, 4, 2 more, 5, 6, for a grand total of y to the 6th power. All right, our last example in our product of powers, what about this one? What if it was x to the 5th times y to the 3rd? Go ahead and try that one. Pause the video now. All right, let's talk about this. So it is a product, and it does have powers, but are x and y the same base? Not the last time I checked, right? Let's see what happens when we try to expand it. What's x to the 5th actually mean? That means x times x, 5 times, 1 more. All right, that's x to the 5th, right? X times itself 5 times. What's y to the 3rd actually mean? That means y times y times y. Y times y times y. Now, how many total times am I multiplying x? 1, 2, 3, 4, 5. Wait, that's a y. So I can't say x times y is x to the 2nd. Like, that doesn't work. So I'm multiplying x by itself 5 times. And how many times am I multiplying y? Only 3 times. So if you notice, that's why the product of powers only works when you're multiplying powers with the same base. All right, let's take a look at our quotient of powers next. All right, moving on to our quotient of powers property. Quotient of powers means you're dividing powers, again, that have the same base, and that is very key, same base. So go ahead, take a moment and set up your notes again with our 3 columns: expression, expand, and simplify. Once you've done that, let's go ahead and get started with our first problem. Now, we are looking at quotients, and we're going to be using fraction bars to look at our quotients today. So just like we did in the last example with products, let's start off with some integer bases. So now let's say I have 2 to the 5th power divided by 2 to the 3rd power. So again, let's double check this is a quotient of powers. Am I dividing? Yes. Are they powers? Yes. And do they have the same base? Yes. So let's go ahead and expand. Now, keeping our fraction bar, because we have a power in the numerator and a power in the denominator, we want to make sure we keep those separate. Let's start by expanding the numerator. 2 to the power of 5 means 2 multiplied by itself 5 times. 2 to the power of 3 means 2 multiplied by itself 3 times. Now, not like product of powers, you'll notice you're not continuing on multiplication. You're actually dividing 2 by itself a couple times here. I ask you, what's 2 divided by 2? That's 1, isn't it? In fact, in high school, we call that a big 1. When you multiply the same number by, or excuse me, divide the same number by itself, we call that a big 1. It's equivalent to just 1. So what you get to do is grab maybe a different colored pen or a highlighter, and we can go in here and I can say, oh, 2 divided by 2, that's 1. In fact, that's not the only time it happens. It also happens here, 2 divided by 2, and here, 2 divided by 2. So where does that leave us with? That leaves us with 2 times 2 in the numerator and just 1 in the denominator, because all of the 2's in the denominator turned into big 1s. Well, now let's go ahead and simplify that, and let's write that as a single power. So 2 times 2, I know you're like, oh, it's 4, but let's write it as a power. 2 times 2 is the same thing as 2 to the power of 2. And then we have 1 in the denominator. But when you get to high school, you don't want to leave that 1 in the denominator. What's 2 to the power of 2 over 1? That's just 2 to the power of 2. And that's how we simplify with a quotient. So a quotient, you have to have the same base because we're going to look for some big ones. Let's try another example, this time with some variables. So what if I had x to the power of 4 divided by x to the power of 6? Is it a quotient? Yes. Are they powers? Yes. And do they both have the same base? Yes. So let's go ahead and expand. X to the power of 4 is x multiplied by itself 4 times. X to the power of 6 is x multiplied by itself 6 times. Now, it kind of seems weird, but if you think about it, x and x are the same number. So what's x divided by x? That's still a big 1. So now grab a highlighter or a different colored pen. Let's go in there and find our big 1. X divided by x is a big 1. X divided by x is a big 1, another big 1, and another big 1. So that leaves us this time with 2 x's, x times x in the denominator, and only 1 in the numerator. So let's write out what that actually means. X times x, that's just x multiplied by itself 2 times. That means I have 1 in the numerator and x squared in the denominator. Now I ask you, is that the same as just saying x squared? Can we get rid of this 1 like we got rid of the 1 in the first example? No, the answer to that question is no, because this became a fraction. And when you have 1 in the numerator, 1 divided by x squared is not the same as x squared divided by 1. So no, we cannot say this. No, 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 no. Our final answer is just 1 divided by x squared. All right, I'm going to give you an example to work on now. How about m to the 3rd divided by m to the 6th? Go ahead and try that by pausing the video now. And let's go over it. So here we go. Let's expand. It is a quotient of 2 powers, same base in the numerator, m times m times m. In the denominator, 6 of them, times m, times m, times m. All right, let's see here. Do we have big ones? You betcha. M divided by m is 1, another 1, and another 1, leaving us with 1 in the numerator. Notice the 1 always goes where all of your factors have turned into 1s. I like to put a placeholder 1 there. What do we have left? Well, we have 1 in the numerator. And m times m times m, that's m to the, how many are there? 1, 2, 3. Whoops, there goes my pen. That would be m to the power of 3. Again, does that equal m to the power of 3? Can I just write it like that? Can I just get rid of that 1? No, when you have a 1 in the numerator, that's not the same as a 1 in the denominator. That's just 1 over m to the power of 3. Now, let's look at an example that has this 2 different bases like we did last time. What if I had x to the power of 2 over y to the power of 3? It is a quotient and there are 2 powers, but are x and y the same? No, they're not the same. So when I go to expand, x to the power of 2 is x times x, and y to the power of 3 is y times y times y. Does x over y, is that a big 1? No, that would be like saying, does 2 divided by 3 equal 1? Does 5 divided by 7 equal 1? No, so there are no big 1s here. There's nothing that I can do. All I can do is leave this as x squared divided by y to the 3rd power. There's nothing else I can do. So that's why it is important to understand that this quotient of powers only works when you have powers with the same base. All right, let's wrap up these notes with our power of powers. Okay, for our last property, we're going to look at a power of powers, which is a power raised to another power. Notice I didn't write same base here because that's actually not as important. So take a moment to set up your notes in your 3 columns with expression, expand, and simplify. And let's get started. So just like we did last time, we're going to get started with an example using an integer. So let's say I have 2 to the 2nd power raised to the 3rd power. So notice this is a power raised to another power. In other words, you're going to see 2 exponents because you have the one inside the parentheses and then the one outside of the parentheses. So when we expand this, we actually expand this in 2 steps. The first step is I want you to think about what this 3 actually means. This 3 means whatever's inside the parentheses, I'm going to multiply that by itself 3 times. So that means I'm doing, and I'm going to keep it in parentheses just to show, 2 to the second power times 2 to the second power times 2 to the second power. Because the base of this power is 2 squared. So that's 1, 2, 3. So that's your first step, is expand just the outside power. But now we still have these powers, right? So really I should write expand the powers here, because you want to fully expand it before you can simplify it and write it as a single power. So now our second step is to go in and let's expand all of these individual powers. So think about what this means. 2 to the power of 2 just means 2 times 2. And remember, this is multiplication here, so I'm just continuing that on. 2 times 2 times 2 times 2 times 2 times 2. That's your second step. So the first step, again, expand the outside power, then expand the inside power. Now this is going to look more similar to our product of powers because we're just multiplying all of these bases. So our base is 2, and how many total times am I multiplying it? 1, 2, 3, 4, 5, and 6. So my final answer here would be 2 to the 6th power, and if you wanted to fully simplify that, you could. All right, let's look at a second example, this time using a variable. So let's say I have m to the 5th power to the power of 2. M to the 5th power to the power of 2. Is this a power of powers? Let's see. I see a power raised to another power. In other words, I have 2 exponents. That's how you can tell that this is a power of powers. So step 1, let's first deal with the outside exponent. So this is telling me to multiply m to the 5th by itself 2 times. So I'm going to have m to the 5th times m to the 5th. And I do like to keep it in parentheses just because I don't want to lose my exponent anywhere. Okay, now this has kind of become a product of powers. Step 2, let's expand m to the 5th and m to the 5th. So m to the 5th means m times multiplied by itself 5 times. That's m times m multiplied by itself 5 times, 1, 2, 3, 4, 5, times 5 more, 3, 4, 5. So I started by expanding the first power. Now I've expanded the whole thing. And now I can write my answer. I can simplify as a single power. How many total times am I multiplying m? Well, there's 5 here and 5 more there for a grand total of, count them up, 5, 6, 7, 8, 9, 10. M to the 10th power. All right, why don't you try this next one on your own? You can pause the video when I tell you to. Let's use R. How about R? How about R to the 2nd power raised to the power of 4? Go ahead and pause the video now to try that one on your own. Okay, let's go over it. Step 1, start with the outside power. So this is telling me to multiply R to the 2nd power by itself 4 times. R to the 2nd power times R to the 2nd power times R to the 2nd power times R to the 2nd power. So I've got 1, 2, 3, 4. So the first one, the first power is done. Now let's go in there and separate all of those powers and expand all of the individual ones. What does R to the 2nd power actually mean? It means R times R. So here we go. R times R times R times R times, notice that I'm emphasizing this because I'm just continuing this multiplication. R times R times R times R. Whew. Okay, how many total times am I multiplying R? 2, 4, 6, 8, or 1, 2, 3, 4, 5, 6, 7, 8. So I would write my final answer as R to the power of 8. And that's how a power of powers works. So it doesn't really matter if you have the same base or not, because really we're just dealing with single powers. Now, to end this video, I'm going to bring back all of our examples from power, quotient, and product. And we're going to look for some patterns. Okay, let's wrap this up. So here are our notes from product of powers. And here's my question for you. I want you to look at the expressions that I gave you and the answers that we ended up with. Is there a pattern? We had 2 to the 3rd times 2 to the 4th, and our answer was 2 to the 7th. X to the 5th times x squared, x to the 7th. All of these, y to the 6th. Do you see a pattern? If so, go ahead and enter that answer in now. All right, now same question for quotient of powers. Let's look at our examples. We had 2 to the 5th divided by 2 to the 3rd, and our answer was 2 to the 2nd in the numerator. We had x to the 4th divided by x to the 6th, and then our answer was x squared in the denominator, so 1 over x squared. We had m to the 3rd over m to the 6th, and our answer was 1 over m to the 3rd. Do you see a pattern here? If so, go ahead and answer that right now. All right, last question in our power of powers. Do you see a pattern here? We had 2 to the 2nd power raised to the 3rd power, and our answer was 2 to the 6th. We had m to the 5th power to the 2nd power, and our answer was m to the 10th. R to the 2nd to the 4th, our answer was r to the 8th. Do you see a pattern? If so, go ahead and enter it in now. Great job, young Padawans. We're going to discuss those patterns maybe tomorrow in class a little bit later on. I'll give you hints. There are definitely patterns, or what we can sometimes call shortcuts later on. But great job. Let's get ready for our exit ticket.